Hello everyone, welcome to lesson 3-8, Solve Systems of Equations Algebraically. We will continue to address the question, why are graphs helpful? And the vocabulary for today is substitution. Let's take a look at a real-world example of systems of equation. Jewelry. Marianne sold 20 necklaces and bracelets at the craft fair. She sold 3 times as many necklaces as bracelets. So 3 times as many necklaces as bracelets. So bracelets would be 1 and necklaces would be 3 times. So if we were to draw this out to give us an image, right? We see here that we have X being represented by bracelets, so she sold this many bracelets. We don't know what this number is, but we do know that necklaces are 3 times that amount, right? You can see if we were to cut it, we would have 3 equal parts. And the total of all this would be 20, right? An equation to represent the bar diagram is x plus y equals 20. X bracelets plus y necklaces will be 20, right? Marianne sold 3 times as many necklaces as bracelets. Divide the necklace bar into sections to represent this. We've just done that in the previous example where we would separate it like that. Right, and we have X bracelets, and down here we have Y equals 3 times X. Y is X 3 times the amount of X, right? Makes sense. Write an equation using only X to represent the total number of necklaces and bracelets. So using only X, what we want to do is we want to say X plus 3X, 3 times X equals 20. What that means is, right here, I have my number of bracelets, right? And over here, I have bracelets again 3 times. This 3 times the number of bracelets is my necklaces. And it all equals 20. You're probably wondering, why didn't I just write it as 4x equals 20? I could. Because this is 1x plus 3x, these are like terms, I could add them up to simplify, and it would become 4x equals 20. Solve the equation from step 2. What does the solution represent? Well, if I have 4x equals 20, 4 times the number is 20, 4 times 5 equals 20, right? Or I can just divide. Remember how we isolate and invert? So I divide both sides by 4. Gets rid of the 4 here. Now I have x equals 5, sorry. X equals 5. So if x equals 5, we can say that Mary sold 5 bracelets. And if Mary sold 5 bracelets, that means that she must have sold 3 times this amount in necklaces, which would be 15. So let's write that out. We have 5 bracelets right there and 15 necklaces for a total of, sorry, that 15 is kind of messy, for a total of 20 items. So the main point of this lesson is to solve a system of equation algebraically, right? Solve a system algebraically. In the previous lesson, you estimated the solution of a system of equations by graphing. Substitution is an algebraic model that can be used to find the exact solution of a system of equations. Let's take a look at what that means. In the first example, we have solved the system of equations algebraically. So we have y equals x minus 3. Oh, if you're familiar with the types of equations, you've probably noticed that this looks like intercept, right? Y-intercept. And here we have y equals 2x. Since y is equal to 2x, you can replace y, so here's our substitution, with 2x in the first equation. So if we're saying that y is 2x, let's replace it right here. This could be 2x equals x minus 3. You see? Replace it right there. 2x equals x minus 3. Now we want to try to isolate the x, but we're going to do something we've never done before. We typically try to, for example, we would divide the 2 out of here and divide it out of here and so on to try to isolate the x. But if you notice, here we have 2 x's, x and x. X plus x equals negative 3. why not just simply get rid of the x on this side, one of them, so I'm left with only one x on this side, and then it gets rid of the x on this side, and I'm left with my -3. So what we're going to do is use the subtraction property of equality, okay, but with the 1x. So if I subtract it from both sides, I'm simply left with 1x here, you see it there, and I'm left with a -3. So this gets canceled out, and 2 gets canceled out there, so I'm only left with the x, as you see there. So x equals -3. Since x equals -3 and y equals 2x, then y equals -6 when x equals -3. So this is a condition. When, okay, then y equals -6 when x equals -3. Because 2 times -3 equals -6. So y, right here, is -6 when x equals -3. Only when x equals -3, as we figured out here. Then the solution of this equation is -3, -6. And you can see where it's been graphed right there. You have x equals -3 and y equals -6. There we go. And that's the solution where the two lines intersect. Okay, here we have the examples or the practice, for you to try. Go ahead and pause the video and try these two and then check your answers with me. Pause now. Okay, we have y equals x plus 4. We know that y is 2. So let's replace that variable right here, up here, right where we have 2 equals x plus 4. All I've simply done is I've taken my 2 and I replaced it here, right? I took 2 and I replaced the y. Now I can go ahead and solve for this equation where I can try to isolate my x, right? I bring my positive 4 over to the other side, okay, which becomes -4. So it's going to be 2 minus 4 equals x, and now I have -2 equals x. So if x is -2, I can have my coordinates as x is -2 and y is already 2. It's been given to us. There it is. So those are that is my solution. That is the solution of the system of equations right there. -2, 2. Question B. Okay, y equals y equals x minus 6 and y is 3x. Okay, let's replace that 3x right here in the y because that's what y is. And now I have 3x equals x minus 6. Okay, now how would I isolate this so that I'm able to identify what my x is? Well, I could simply bring this x over to the other side and subtract it, right? So it becomes positive x, or I can do subtraction property of equality, like I did before, where I had subtract the x from both sides so that it's gone, or I can simply convert and isolate. But I'll just subtract the x from both sides, right? So that I get rid of it on this side. So x is gone here, and over here I'm left with 2x equals -6. And then when I divide that, I'm going to continue my lines over here because it's pink here and you won't be able to see my writing. So I'll continue here. When I divide that, I'll rewrite it. I have 2x equals -6 so far. I'm going to divide the 2 from both sides, right? So I can get rid of the 2 here. Now I have x equals -3. So if x equals -3, I already have my x coordinate, right? I can say my x coordinate is -3. What is my y? Well, I need to solve for y, and I'm going to do that over here. If y equals 3 times x, x is -3, so this would be 3 times -3, right? It would look like this. Y equals 3 times -3, because x is -3. So my y equals -9. And there's my other coordinate, -9. There is the solution of this system of equations, -3, -9. Okay, now we have another key point here that we have to pay attention to. We have slope intercept and standard forms, the two types that we have practiced already. Sometimes one or both equations are written in standard form. When solving a system by substitution, one of the equations should solve for either x or y. we're going to be told what y is. So for example, when we have an equation written in y, intercept, for example, like y equals 2x plus, you could say 6. You could substitute wherever y is. If you're solving for y, you can substitute y by inserting this part of the equation, because we're saying that this is y. And then in the equation, now that you've substituted for y, you should have only the variable of x. At that point, you know how to solve for x. Just isolate the variable and solve. And we can see that in example 2. You see how we have y equals 3x plus 8, and then we have as a standard form of 8x plus 4y equals 12. Okay, let's solve for y. We can solve for x here. We can solve for x by inserting y, what we know. And we know that y is 3x plus 8. So let's take this 3x plus 8 and put it right in here. Okay, and then we can use distributive property to solve. You see that? We have 8x, just as we do here, plus 4y. Well, the y is being replaced with 3x plus 8. See, because y is 3x plus 8 equals 12. Now we can do distributive property, okay, and solve. Or what they've done here, what they've chosen to do, is just set it up where it's 4 times 3x plus 4 times 8. Or again, distributive property. This would be 12x, and this would be 32. There it is. 8x plus 12x equals 32. Now we just have to solve for x. I have 20x's here, plus 32 equals 12. Okay, let's get rid of the 32 on both sides, or just let's invert, bring 32 over to the side, subtract it, as we've done here. And now I have negative 20x equals negative 20. Divide both sides by 20, and x equals negative 1. Now that I have my x equals negative 1, I can take this and substitute it here. Sorry, here, right here. Right? And I can solve for y. This would be 3 times negative 1. It's negative 3. Plus 8 is 5. So my y should be 5. Is it? There it is. Okay. Yeah. In my system, the solution of my system is negative 1 and 5. Okay. If you think you got that, and you know how to do substitution, pause the video now and try C and D. Pause now. Okay, question C. We see here that we have y equals 2x plus 1. So that's what y is. Yeah, I could insert it in here. And I have 3x plus 4y equals 26. Okay, let's solve for the first one right here let's solve for this equation by taking the first one and inserting it here. So that it's written now like this: 3x plus 4 times 2x plus 1, right? This right here, equals 26. Okay, let's do distributive property in here, where I multiply my 4 times both of those. And now I have 3x again, plus 4 times 2x equals 8x, plus 4 times 1, right? 4 times 1 equals 4, equals 26, right? Now I have 3x plus 8x is 11x, plus 4 equals 26. We can bring this plus 4 over to the other side and becomes minus 4. So now it's 22 on this side, and it's 11x on this side. And now I gotta go up here because I'm out of room. 11x, I'm gonna divide 11x divided by 11 on both sides to isolate the x. So I have 22 divided by 11, and I have x equals 2. Now that we know what x is, we can take our x and now substitute it into this equation right here, so that we know what y is. So, and when I do that, I have, I'm just going to write it above it, 2 times 2, because x is 2, plus 1. 2 times 2 is 4, plus 1 is 5. So my y equals 5. So now I have the solution of the solution of this system equations, which would be x is 2 and y is 5. Let's try the next one. Question D. You can see that we have our y is 6x minus 4, so let's replace it in here. So I'm going to rewrite the first one of 2x plus 5, and I'm going to write in what my y is that I've been given. Y is 6x minus 4 and the whole thing equals 44. And now I can go ahead and solve. I'll do distributive property here, 5 times 6x and 5 times negative 4. I'll begin by writing my next line, plus 5 times 6x equals 30x, and 5 times negative 4 equals negative 20, and all that equals 44. Add these two up, right, and I get 32x minus 20 equals 44. Take that negative 20 to the other side and it becomes plus 20, which would be 64, and I have 32x. So 32x, and I divide both sides by 32 to isolate the x. That's gone, and divide this side by 32, and I get x equals 2. Okay, there's my x. Now let's take that x and let's replace it in here. So that now it becomes 6 times 2 minus 4. That'll give me the value of my y. So y equals 6 times 2 is 12, minus 4 is 8, equals 8. So the solution of this system of equations is x equals 2 and y is 8, and that is my coordinate. Example 3. A total of 75 cookies and cakes were donated for a bake sale to raise money for the football team. There were 4 times as many cookies donated as cakes. Okay, so we have this many cakes and 4 times the amount of cookies for a total of 75 baked goods, right? So what does that look like? X is simply my cakes, that's one value, and y is going to be 4 times x. As you see here, y is 4 times x. And I know that x plus y is 75, right? My x plus my y is my 75. There were 4 times as many cookies donated as cakes. The total number of cakes and cookies is 75. We know that, right? And with that information, we can use substitution to solve, okay? Where we know that y is 4x. So there's our 4x. We add them, and I have 5x. And I isolate the x, I divide, and I get x is 15. So if x is 15, I can simply embed 15 here or subtract 15 from this side, and that's my y. So my y is 60. So the solution to the system of this equation is 15 and 60. Okay? Now we can do the same here. If you think you know how to do it, please go ahead and pause the video now and try this question. Pause now. Okay, I hope you paused the video. Mr. Thomas cooked 45 hamburgers and hot dogs at a cookout. Okay, 45 hamburgers and hot dogs, sorry. He cooked twice as many hot dogs as hamburgers. Well, I think some of you guys can figure this out simply by looking at that number. I already figured it out that he would have cooked, because he cooked twice as many hot dogs as hamburgers, so he cooked 15 hamburgers and 30 hot dogs. 30 being double this, right? 30 being double than this number, and together the sum is 45. Simply by looking at it, I could figure it out, but let's actually write it out the way it's supposed to be. Write a system of equations to represent this equation. So what we're saying is that we have x, right? We have our x is one value, and we have our y. We have our y will be represented by the number of 2x. Yes? 2x. And we know that x plus y is 45. Okay, those are my equations. I know that my hamburgers, because you cooked this twice as much hot dogs as hamburgers, so my hamburgers plus my hot dogs is 45, and I know that my hot dogs is 2 times the number of hamburgers. Makes sense, right? Now we can go ahead and solve, where I substitute. So I'm going to take my 2x and substitute it in here because that's what I've been given. So now I have x plus 2x equals 45. Or 3x equals 45, and divided by 3 on both sides, I get x equals 15. If x equals 15, then I can substitute in here now. Or, sorry, right here. You see, right there. So that if y equals 2x, I can say y equals 2 times 15, because that's what x is, and y equals 30. So, the solution of this system of equations is 15, 30, where 15 is my number of hamburgers and 30 is my number of hot dogs, as I have predicted. And here is our guided practice. This is how we will begin next class. Please take a look through it. Make sure that you feel comfortable with the content. If you don't, go back to the examples in the video. Okay, everyone. See you in class.